First, I want to remind everyone to mute their microphone so we don't have any background interference. And I'm happy to welcome everyone back after the long holiday season. But I'm doubly happy to introduce today's speaker, Ron Ballinger, who is an emeritus professor from MIT's Nuclear Engineering and Nuclear Science and Engineering Department. Ron is one of the people I've known longest at MIT. I knew him first as a student, and then as a member of the faculty, and then as a colleague who serves now on the U.S. Nuclear Waste Technical Review Board, and also he serves on the Nuclear Regulatory Commission on a number of committees. And so I've known him for a long time. I think he is the person who can really guide us through this discussion of the interest of big tech, particularly in resurrecting some of the nuclear power plants that have been decommissioned in order to serve their own particular needs for electric generation. This is an unusual circumstance, and I think it deserves a lot of attention, and I'm glad to have Ron with us today to start that conversation for us. So Ron Ballinger, welcome. The floor is yours. We're looking for your presentation. Thank you.
Thank you a lot. Let me see if I can get this to actually, oh, it does change. Okay.
Yeah.
Well, going to try to give you a little bit of background, and without that background, you really can't put what's going on in the nuclear business with respect to restart and things like that into perspective. And you really have to know a little bit about the evolution of the grid and its requirements. So I'll give a little introduction background, talk about the grid, pricing, data centers, and our ISO New England person will immediately detect that I've glossed over a fair amount, but you'll get the point. And then we'll talk about decommissioning and restart. There's both a regulatory issue because it's never been done before, and the NRC doesn't know how to quite handle it, so they're working on it. And then there's issues related to infrastructure. When you shut one of these things down, a lot happens, and anybody that's being kept track of what's been going on at Diablo Canyon, which is a plant in California, which never really got shut down, but just asked to continue operation after it agreed that it was going to shut down. And that's a couple of $2 or $3 billion costs associated with doing that. So we'll get going here. Okay, let's say a little bit about the electric grid that a lot of people don't quite know about. In the US, there are basically three generation areas. There's one in the eastern part of the country, one in the western part, and you see that Texas is unique in that it's got its own, and it's not governed by FERC, the Federal Energy Regulatory Commission. But those interconnection regions, they're actually connected to each other by DC interconnects. In other words, like a toaster. So to transfer power directly from one of those interconnected regions to the other, you have to go through a AC to DC to AC interconnect. And if you remember what happened with Texas and that area a while back, where a lot of their gas plants and stuff, the lines froze and everything, and they had to somehow get electricity into Texas, they couldn't do it fully because the DC interconnect was overheating. So think about that. Here we are with this AC system, which is, by the way, connected by a bunch of DC interconnects. So we have to think about what we're calling the components of the grid, and I've loosely divided them up as follows. What I would call base load systems. Those would be loosely, again, nuclear, fossil, oil and gas, and the like. And you can always find exceptions, but generally speaking, that's what we're talking about. And they get broken up into what's called dispatchable, which means the ISO guy can say, I need the power now, and there it appears. And then non-dispatchable, which would be something which might be base load, but it takes a while to start up. So the I want ISO, independent system operator. Sorry about that. Um, when he needs that power, he can't rely on it instantly. And then there's issues related to load following, which we all know that the load is a function of time during the day. And so there are certain load serving people, entities, I call them, that can load follow. They can follow the demand, gas turbines, some fossil plants, some nuclear plants, more likely what's called, there's two types of nuclear plants, boiling water reactors and pressurized water reactors. The BWRs are a direct cycle, so they can more easily load follow, though they're not originally designed to do that. PWRs can't change power as quickly, and so they really can't load follow in the sense that varying their output by 20 or 30%, although some of that is happening nowadays. Then there's peaking, which gas turbines, batteries, pump storage, those kinds of things where they're only operating to cut the top off of the load, the demand curve or the load curve. And then there are intermittent. Now I'm going to get everybody mad. They're intermittent. Solar, wind, and tidal would be one of be examples of that. And these are, what we all know. The wind doesn't blow, you don't get power. When the sun doesn't shine, you don't get solar. And when the tide is slack, you don't get tidal. And then in the regulatory business, there's a term of art called intermittent must take. And that's the most important one. Non-must take means you don't care. But intermittent must take is a category in the regulatory scheme where if an intermittent source generator is available, then the local grid must take the power. That's independent of what other sources are providing power and independent of the load, because those other power sources, in order to accommodate the must take part, they have to back off their power. That's a big problem for in some cases gas turbines, but certainly in the case of nuclear, because they can't change power that quickly. So must take is something we'll need to remember. And then there's spinning reserve. And the folks that are big solar and wind and tidal folks, a lot of times they don't start the conversation in the right place. Spinning reserve is required in order for this. What happens when one of the intermittent sources decides that it's not going to be intermittent anymore, and so that the grid needs to make up that power. And more often than not, it's called spinning reserve, which means a base load system or a gas turbine or something like that is just sitting there spinning that that would be available very quickly. So that's that thing. So this is an example of what happens, and it's actually in I think it's ISO New England, come to think of it, and it shows you the difference that you can have between what's available and what is needed. And you can see the effect of solar power. You got this huge amount of solar power that's available when it's not needed. And so what happens is either one of the other sources has to back off to accommodate the solar power if it's intermittent must take. And that really messes up gives the ISO people headaches. Okay, so with respect to nuclear, again, I like to say I've got some good news and bad news. Nuclear is a very good base load source. That's what they're designed for. They're usually large power at least 500 megawatts electric, more like 1100 or 1200 megawatts electric. They have very long life, it turns out. We're now we're now reviewing applications for plants to increase their operating life from 60 to 80 years. So some of these plants are going to be operating, were built in the 70s, and now will be operating for up to 80 years. I might add that there's really no such thing as a 40-year-old or 50-year-old or 60-year-old nuclear plant, because most of all of the components in that plant have been replaced, with the exception of the pressure vessel, the concrete base mat and stuff like that. But most of these plants have been kept up by replacing components. They have relatively low fuel costs, and the fuel is, I should put that in quotes, a stable source, because uranium is available in the US, and it's available in other places that are more reliable. Unfortunately, we now get a lot of our uranium, and with this big controversy, from not so reliable places like Russia, but it's competitive now with other baseload sources. In the early days, it was definitely not competitive, because the availability was bad, because we had poor operation, mostly materials issues and things like that. But nowadays, they're quite a bit reliable, very reliable, and so they can compete with other sources. If you talk to folks down in Virginia, the nuclear plants down there can compete easily with gas. And if you're a climate change person, these plants don't emit carbon. They're not carbon emitters. Although you can argue that, well, you got to start with back when you mine the uranium. True, but nonetheless, if you're a climate change person, then these plants can help you there. And I'm constantly amused by the gymnastics that the anti-nuclear folks have to go through to somehow justify using nuclear when they try to balance their carbon emission goals. So, okay, the bad news is the overnight costs are very high. We're talking on the order nowadays of $2,000 per kilowatt. If you talk small modular reactors, some of the things that are that's the real buzzword nowadays is SMR. Some of those plants, which gives you an idea of whether they'll ever actually get built, we're talking $8,000 or $9,000 a kilowatt, which is nuts. Until that cost comes down, nobody's going to build one of these things. They do have limited load following capability. That's what I mentioned earlier. They don't like to be cycled up and down. And they're often, I said, well, they're competitive now, but they're often not competitive, primarily because when you consider subsidized sources, which, by the way, solar and wind are heavily subsidized depending on the location in the country, and batteries, then they're not competitive. We'll talk about how the finances work, but if you check your electric bill next time you get it, and in the state of Massachusetts, they're required to tell you what your electric bill is composed of, you'll discover that 30 or 40% of your electric bill goes to subsidizing sources of electricity, which, if they weren't subsidized, things would be a lot different. Okay, what about pricing? Many years ago now, we deregulated the utility environment, the power generation environment, with the concurrence of our friends called FERC, which is the Federal Energy Regulatory Commission. there are now there are two types of service in general. There's one called cost of service, and that's the one that before the deregulation we were most familiar with, and it was criticized as being a boon to electric utilities and the like. And in that thing, there's a utility commission, and wherever you are, and the utilities would come to the commission and say, by the way, here are our costs. And the commission would say, okay, these are good or not so good. And then they would add an agreed upon return on investment. And so the total cost of generating the service was covered by the customer base. And if you go to Georgia, places like that, they have, generally speaking, a cost of service environment. They're not real fans of the banks are not real happy about this because of cost of service. You can pay as you go if you want to. And then the other type of service is called capacity service. And that's what we have here in the Northeast. And so in that system, the ISO people, and we probably have a member here that probably can expand on this ad nauseum. The ISO people go out for a bid and they say, we need this much power. And by the way, it's almost every 5 minutes. It's very, very continuous. And the various load serving entities would say, okay, I can supply X at this cost. And then some other one will come in and say, I can supply Y at this cost. And then what happens is when the ISO gets to its required amount, that's called the clearing price, and everybody gets that cost. Now, if you're a nuclear plant, in many cases, what happens is your operating cost can't compete with the other sources. So you go to the ISO and say, I can give you this much power, but it'll cost you this. The trouble is they can't make the clearing price. And so what happens is a lot of times, and it happened is Seabrook plant here, is that they'll bid zero. In other words, they will guarantee that they'll get the clearing price by bidding a cost which is way below, they bid zero, way below their actual operating costs. So they generate the power, but they lose money. And that's where the intermittent must-take thing comes in. Because in a lot of cases, some of these the ISOs, if you would call them that, they're forced to take power when it's available for these intermittent must-take by law. And so what happens is when that happens, they can use their subsidy to underbid everybody else. So that's the kind of general thing that what's happened. But by the way, the poor slobs that had to bid zero, they're the ones that are responsible for what? Spinning reserve. So they got to keep something online just in case the solar and the wind and the other subsidized sources become unavailable right away. So that's the pricing thing issue that's important to think about. Okay, let's see. All right. So now there's this changing environment we're talking about here. Again, in the early days, the nuclear plants their availability was just terrible. No doubt about it. The startup cost, people were betting the company and losing, and their maintenance costs were outrageous. And so if they were 50% availability, they were probably lucky. But that's not the case now. So in past times, the generating costs were high enough, and so they couldn't compete with these subsidized sources. And so a lot of them started shutting down. And there are 90 sites nowadays with plants on them. We used to have 120 or thereabouts. Some of them were just shut down for old age and everything. But some of them, in the case of Palisades, and the case of TMI, and in the case of, at one point, Diablo Canyon, but San Onofre was certainly one of those cases out in California. They just shut down for economic reasons. Again, I mentioned these load following limitations that would be very difficult for them to deal with because of this intermittent must-take thing. I keep harping on that, but it's just one of those things. But what's changed? Well, if you go to up to the town that I live in, up in Andover, there's another town north of it called North Andover, and there's an Amazon distribution center there, and that sucker is huge, absolutely enormous. And they're wanting to build what's called a data center. What's a data center? We're an internet connected world nowadays, and these data centers, every time you click on your mouse or something like that, that translates into using a little bit of power. And there's millions and millions and millions of these little clicks that happen every minute. And every one of them requires power. So these data centers that Amazon and Microsoft and name a big company want to use, and they are sometimes 700 megawatts or more. Huge, huge, huge sinks for power. And if one of those things dies instantly, goes offline, or it's not needed anymore, there's an excess of power that's available to supply these things that's really hard to deal with. All right. Plus, 700 megawatts is a lot of power to supply. And so some of these big companies, in fact, in particular, Amazon and Microsoft, are entering into what are called long-term power purchase agreements. They're saying, okay, they'll go to a utility or a source and say, okay, we'll pay you this much for 20 years or 30 years if you supply us power. And they say, okay, well, that's going to be tough. And they said, well, we need it reliably. Ah, you need it reliably. So what happens is the deals that people are making, in particular with Three Mile Island Unit 1, they want to put a data center, what's called behind the meter. All you solar gurus and stuff like that with solar panels on your house, that power that's going into your house is behind the meter. In other words, it's generated and supplied to your house, and you're being asked to pay for it in one way or another a little bit, but more or less behind the meter means you don't have to pay transmission costs and things like that. Well, put one of these things behind the meter that's 700 megawatts. And that's power that the ISO guys are going up the imaginary axis, because if you got one of these things behind the meter, they're not paying for transmission costs. And that's a big deal. But if the power goes, if that just data center or that power source goes out, then that ISO is responsible for all of a sudden supplying 700 megawatts. So you can see what's going on. And so that's called, if you think about it, co-location. So you take the power plant and you put the data center on the same island. And that's what's going to happen, or they want to happen at TMI. We don't know what's going to happen at Palisades because it's in a different location. We'll say that the Holtec people that acquired Palisades, my cynical, it's not so cynical. I think that their issue is they need a site, and they need a site for their SMR. So they need a site that's already licensed so they can put their small modular reactor on it. And so small modular reactors do enter into this picture, but that's pretty much in the future. So that's what's changed. And so it turns out that these long-term power purchase agreements literally will pay to get these decommissioned or at some state of decommissioning plants back up online. And so you can see the amount of money that gets changed hands is enormous. Okay. why would you want to restart one of these things? Well, in a lot of cases, the power is just not available otherwise. There's no source. But you have an existing site, and Palisades is a good one, and TMI is a good one, and there are others. That means you have the existing infrastructure, power feeds, all this kind of stuff that you need for these things that you don't have to build out if you're starting from greenfield. There's this issue of co-location, and again, the future SMR, small modular reactor location. And so the potential plants that I've listed here, there are probably that I know of that people are asking us about at the ACRS. Palisades is one, and that's the first one, and that's actually in the process of going through the restart process. TMI Unit 1 is another one, which is much less further along. It's just in the talking stages. And then there are others. And I put Diablo Canyon on that list. It was never shut down or decommissioned, but it had the operator had committed to the California government to only operate the plant beyond a certain year, and I forget what the year was. But given the power issues out there, I think they finally realized that with their carbon issues, they really have to keep it running. And so they've gone back and said, okay, we need to keep this thing running. But you'll see that that's easier said than done, even for an operating plant. Okay, what happens when you shut a plant down without the intent to restart, which is what these plants are? It's an economic problem. They just say, okay, we can't run the plant, we're going to shut it down. Well, as soon as they make that commitment, that's to say they notify the NRC that they're going to cease operations, all maintenance stops. And I don't know if anybody's worked at one of these plants, but the maintenance is continuous, and it's even though the O&M costs are not that high, it's expensive. Any planned upgrades, replacing steam generators, mitigating wells, and all kinds of things, those things stop. The plant had been operating safely all this time, so we're going to shut it down. Why should we do any upgrades? And then there's a term that in the Navy and in the power industry we use called layup. When you shut one of these plants down, what condition do you leave it in when you shut it down? But that depends on the long-term intent. If you think that you may restart at some point in the future, when you shut the plant down, you do that with that intention in mind. If you don't have that intention in mind, then they just, in the words of Cosell and the NFL, turn the lights out, the party's over. And they just turn the lights out, defuel it, and they leave. And so things happen when you do that, which if you're going to decommission the plant and disassemble it, you don't care. But if you end up having to think about restarting, that degradation that has occurred during that time that's been shut down, that's a big deal. And if we talk about Palisades, we visited them in 2014 and then 2017. But fact of the matter is, they operated their steam generators in, let's just say, a non-optimum way. The steam generators were operated like a toilet. And so they degraded. And the tubing in those steam generators was an old type of material. And when they went to try to start this thing up, they discovered that they had so far over 1,000 steam generator tubes that needed plugging. And that's not going to change. It's going to get worse. And then from a licensing point of view, there are emergency core cooling system issues and the like. But the degradation, primarily materials related, has occurred, and they're going to have to deal with that. And somebody said there are the unknown unknowns. When they start to go to restart this plant, if you've ever operated a steam plant, you know that the worst thing that can happen is shut it down. And so there are unknown unknowns when they go to start this plant up from a materials point of view that they're that are going to prop up, and they're going to be difficult. So that means that there's the potential for very large costs just to keep Diablo Canyon running and bring it back up to the specifications that they're for the plant. They're asking for $3 or $4 billion for a plant that's actually still operating, right? And that's where the importance of this long-term power purchase agreement is very, very important, because without that commitment, nobody would ever even build one of these plants, much less restart it, unless you had a source of income that would allow you to recover those costs. Now, there's not just materials issues, but there's regulatory issues. The so-called Advance Act and the so-called, I keep forgetting the acronym for that other one before that, but the one before that, gosh, there's a lot of money available for plants that want to restart, and you can apply for loans. And a lot of these people have applied for that, and we're talking 500 million, $1 billion loans. But there's currently no regulatory structure for returning to operation. In other words, there's no rule. You can't go and look up a rule and say, how do I do this? It doesn't exist. And so they're having to start from scratch to either generate a new rule, regulatory rule, and to make sure that somehow the conditions of the plant are adequately established, and then asking the question, how do I go from here to a plant which is in effect ready for operation with respect to inspections, approvals, all kinds of things like that. And so right now, the NRC has established what's called a restart panel for Palisades. And they keep using the word Palisades because they're the guinea pig. They're the first ones. By the way, Holtec has never operated one of these plants. The utility that operated the plant before this, they shut it down. They were decommissioning it. And Holtec, what do they do for a living? Well, they take care of spent fuel. They store it. They build dry storage systems. So Holtec itself has never operated a plant. And so they have to deal with that as well, not just the licensing issues, but the fact that they've never operated a plant. And they're fortunate in that part of where Palisades is, let's just say it's fairly sparsely populated, and people that had jobs up there remained up there. And so a lot of the older employees and stuff are coming back, but it's still only 50% or so of the staff that they can find that previously operated the plant. And so I should mention, I sit on this bottom here, there's something called a PRM, petition for rulemaking, that people that have been submitted to the NRC to ask them to come up with a rule related to Palisades, that asks the commission to develop a new rule. They won't do it for Palisades. They'll have to go through this laborious process of changing, getting exemptions, all kinds of things like that before it gets done. But if more than one plant decides to restart, they'll have to go through the process of developing a rule. And I don't know if you've ever interacted with the NRC, but they do things on a more or less geologic timescale. Things take a long time to happen there. Okay, what are the infrastructure issues? Just configuration verification. They don't, sometimes when they turn the lights out and leave, the records get murky. So you have to go back and actually verify that the plant is what they say it is. Aging management. I say that there are no plants that are X years old because of the aging management that's been going on. And that's very extensive and very, very good. And so if you stop your aging management programs, you have to restart those. And that's, again, you have to go back and find out what your initial state was, and it's a huge issue. Quality assurance is an issue, um, as well as quality control. Equipment maintenance, that's something, TMI, by the way, sold their steam generators and they're gone. I mean, and they sold their turbine and it's gone. So when you're going to restart the plant, what do you're going to have to buy some stuff, and you don't get that stuff at Walmart. Uh, Qualifications of personnel, licenses, operating licenses have expired. What is the appropriate licensing basis for the plant? If you got one of these plants that's been in decommissioning for a long time, is the current power rating or the previous power rating, is that appropriate for the restarted plant? What is the licensing basis to operate the thing? And then there's the whole issue of startup testing, and the last but not least is when you shut one of these plants down, what happens is when the plant was operating, they had what's called an emergency planning zone. That is to say, you go out X miles from the plant, and the owner, to some extent, has control of a smaller area. It's owner-controlled area. But the emergency planning zone is, well, if you have a bad accident, what do you do? What do you do about evacuating people within this so-called emergency planning zone? And when you defuel the reactor and shut it down, you say you're going to decommission it. What happens is that EPZ, it's called EPZ boundary, because you don't have any fuel in the reactor, that gets moved way in. And so now the site boundary, the EPZ boundary, is much smaller. And now what do you have to do? You have to go out and you have to reestablish the EPZ. And that now you're involved with other kind of regulators. And this is a list. You can just look at it. It's just complicated, too many words. But it compares a decommissioned site with an operating reactor. And if you take the time to read it a little bit, you'll see there's a big difference. There's a really big difference. And by the way, that slide is from a presentation that we got at the ACRS by the Palisades people. So the emergency plan update, again, I've already mentioned this. You got a permanently defueled emergency plan. That eliminated a lot of the requirements for offsite. And so that's a big deal. And then the Holtec people, when they were shutting the plant down, they made requests to the NRC to do just exactly what I've described. Move in the EPZ boundary, do all kinds of things. And now they're having to not renege, but revise things so that they can expand out and establish a new EPZ for an operating plant. Okay, so again, my personal opinion is this so-called skewed financial environment should never have been allowed to occur. The idea of a capacity market for a critical national asset, regardless of who's generating it, is probably not a good thing. Probably was not a good thing. That amount, heavy subsidization and FERC deregulation. The FERC, if you talk to, we could, in the question and answer, our ISO person can tell us about FERC. The deregulation is really tough. And bottom line is we've been robbing Peter to pay Paul, and that never works. And I think that's it, my friends.
Great, Ron. Thank you so much. Number one, I want to say I appreciate your perspective on the electric grid. I think that was a useful description and a way for us to begin the conversation, which led to the question of decommissioning.
Yeah.
but
The electric
I have a
grid, by the
question.
way, if you're an electrical engineer, the, the, the big picture was what I said, but there's a
Yeah,
smaller, little bit smaller picture. The electric grid is basically a giant analog circuit with
yeah,
a bunch of digital components. You know, you can buy power nowadays, in theory, you can buy power from Washington State and use it in Massachusetts.
sure.
But if you look carefully at the way the grid is operated, when you, and I use that, when you transfer power from west to east, there's two paths that are available. One that goes north of the Great Lakes and one that goes south of the Great Lakes. And that produces a loop, which is basically a circular loop, which can get to the point where you're basically empty power.
Yeah.
You're wasting power. It's really crazy, really crazy.
Yeah, yeah. No, but I have a question, but just to comment on your what you've just said. I think what you've just raised is one of the arguments that people who are interested in batteries make for local grids, not national grids. And the idea being that instead of having to depend on national resources, you just have local sources, and you can, in fact, you may even eliminate the grid. That's a different issue. I
Yeah,
want to ask, I want to ask a question about
there's a
decommissioning.
big, they're called microgrids.
Yeah,
And
yeah,
yeah, and um, there are batteries that are used, especially in California and things like that,
yeah,
for cutting off the peak. Uh, they've discovered that they don't work.
yeah.
In theory, they work with with
Yeah.
lithium ion batteries. Um, they are, and most lead acid batteries, they're designed to be used and discharged fully and then recharged. The way they're being used nowadays is trickle charging. In other
Yeah,
words,
I don't think anyone
they
does
go,
that.
and that decreases the life by
Yeah,
50 to more than 50% because they're just not this, that technology is not designed to be used that way.
yeah. Well, let me return to decommission. And there are some hands up, so I want to turn to them as well. But let me ask a question. You know, as engineers, I think we're sort of trained to think about risk-benefit analyses. Here's my question. I mean, over the last 10 or 15 years, the number of operating nuclear power plants has been reduced from about 100, I think it was about 124 down to
90, 94,
94.
something like that. Yeah.
Yeah, so there have been a lot of plants that have gone offline. Many of them are in some state of decommissioning. And you mentioned prominently Three Mile Island and Palisades, and they are distinctly different in that sense, aren't they? I mean,
Yeah.
TMI has been in process of decommissioning for, I don't know, 5 or 6 years or maybe longer. Palisades, they were about to start decommissioning, but my understanding is they never really got seriously
Right.
into decommissioning.
Yeah.
And therefore, the questions of material stability and you know the issues you raised and which the NRC has to deal with are vastly different for
Yeah.
each nuclear power plant
Yeah.
that may be considered for decommission for restarting.
Yeah.
How do you deal with that?
Some of these plants are a done deal. I mean, somebody here lives near Pilgrim.
Yeah,
Pilgrim is basically almost greenfield.
yeah.
It's been
Yeah,
dismantled.
and that's true of Maine Yankee and others as
Maine
well.
Yankee is greenfield,
Yeah, yeah, it is Greenfield, yeah.
and so
But
is
how does
Yankee
the
Row.
wouldn't it be sensible for the NRC to say, look, the risks are just too great to restart a plant that's been decommissioned? We're not going to approve it.
Well, again, there's no reason for the NRC to say that because you go to the NRC with a proposal and you say we would like to restart the plant, and they come back and they'll make the determination of whether it's safe to do so. So the decision to try to restart or to do that is really an economic one. I mean, if you want to spend the money and you want to you'll have to comply with what the NRC says, then
But
the NRC is not going to let one of these things operate unless it's safe.
but that's my point. I mean, I guess the question maybe I'm asking a question about that metric. Should it be based on the economics or should it be based on public safety? one more 3 Mile Island event in the United States, and nuclear power could just disappear from our grid permanently. Is
Yeah,
that really,
it's
is the
not.
risk worth that? Is the benefit worth that risk? That's my question.
Again, the commission's not going to let that. The safety side would be verified.
Yeah,
The economics, who knows?
yeah, yeah.
Who knows? So it's really
Okay.
the economics. And I might add, and now I can put my ACRS hat on. We're now in the process of reviewing uh, a new rule that allows for increased enrichment. The enrichment limit was for uranium-235 was 5%, and
Yeah.
people want to go to longer cycles, and so they want to allow increased enrichment um, above 5% in order for that to happen. And so
Hmm.
we're I'm this afternoon having a conference call on this stuff because
Okay.
I chair the subcommittee that's doing that.
Yeah.
But we've had to go through the issues of the commission has come back and said, hey, if you're going to do this, you need to account for the following. And they've listed a bunch of things related to fuel failures during accidents,
Yeah.
which previously have been thought to be of no consequence.
Yeah.
They're now forcing everybody to deal with the possibility of to address those issues.
Yeah. Okay.
And so that's ongoing. And um, but the issues that were present in past years just aren't present
Okay.
with
Well, look, let's take some other hands. We can come back to this, but I see Walter's hand. Let's go Walter first.
Yeah, Ron, I think you've, excuse me, just getting over the flu. Um, Ron, I think you've made a good case for not recommissioning nuclear power plants. The it and so I'd like to add a few things there. First of all, you mentioned that the main source of uranium is Russian fuel sources, and
now or you know former Eastern Bloc or Russia. Yeah.
right, and there's no American that's near completion, or and so we don't have an American source of fuel there. Another one is you haven't mentioned radioactive waste disposal. That's the Achilles heel of nuclear power, and it long has been. Not only of the highly radioactive, but also low radioactivity. Also, the problem with terrorism. And that's a real possibility that we need to guard against. And let's see, as far as switching over to the batteries, um, I think there's a lot of progress being made in batteries for short-term power. In fact, my house has a Tesla Powerwall that was used this summer for um, load shaving, but also the what one of our guest speakers is building a 200 megawatt iron air um, plant in Maine. So there's a lot of progress on the battery front.
Yeah.
Um, just a side note, Holtec, you mentioned Holtec is working on the Palisades plant, and I believe the Palisades plant is in Michigan.
Yep.
But they're also the people who are decommissioning the Plymouth nuclear power station in
Yep.
Plymouth, Massachusetts as well.
Yep.
Yeah.
Yep. They also make dry storage canisters uh, for spent fuel. And
Yeah.
they also were involved with to license or attempt to license a site for what's called monitored interim storage of dry fuel of spent nuclear fuel. It's on the border between New Mexico and Texas or something like that. It was actually licensed was approved by the NRC, but then the state went to court and blocked it. So
Right.
right now there's a licensed facility to take the fuel from plants, a commercial site to, but we'll see what happens there. But again, the DOE made a promise many years ago to take the spent fuel by X date. and X date went by the wayside and they didn't take the fuel, and the utilities have been contributing, so we call it, to the so-called nuclear waste fund. So guess this is
Yeah.
crazy. The waste fund has got billions and billions of so much money in it that the government is using it to say that the deficit isn't what we think it is. Really, it's that amount of money.
Oh, it's not trillions, Ron. It's not that big.
I didn't say trillions, I said billions.
Oh, okay. I'm sorry.
Not trillions. Trillions. Now we're talking about Walmart stock, but
Yeah, yeah, okay.
trillions,
No,
right?
I see hands up, but I have one other question dealing with nuclear waste. When Dan Metley and I were both actively involved with the Nuclear Waste Technical Review Board, there was a Blue Ribbon Commission set up to look at what to do with waste. You remember
Yep.
that? And I remember Ernie Moniz, before he was Secretary of Energy, he was part of the Blue Ribbon Commission. He came to a hearing that the board had, and he said, I'm concerned about permanently burying nuclear waste because it could be that in a new fuel cycle, some of this waste could be repurposed for
Yeah.
and useful.
Yeah.
And so when you talk about where the source of nuclear fuel is and whether it's a stable source, his comment was, yes, we got to deal with nuclear waste, but if we dispose of it permanently, we may be diminishing our potential for
Yeah.
providing nuclear fuel. What's your thought on that?
Yeah, we need to be a little bit careful. First off, it comes down to economics. If this was useful to do, somebody would be doing it. All right.
Yeah.
But reprocessing spent nuclear fuel does not eliminate the waste problem. It just makes it smaller.
Yeah.
In other words, you still gotta put the stuff somewhere.
Yeah. No,
And
that's
so
true.
you make it smaller, but you don't eliminate it. So anybody that says we're going to burn all this fuel and we won't have any waste, we got a bridge that they'll maybe buy as well, or
Okay.
something like
Okay.
that. So it's
All
not
right.
not
Fair
not
enough.
not not happening.
Yeah.
Not happening.
Let's
But
go to
back
Mike.
to the waste thing.
Yeah.
The utilities are now suing DOE because
Yeah.
they failed to take the fuel. So they've stopped contributing to the waste fund. And by the way, they're winning. But guess where the money comes from to pay out? And it's millions and millions of dollars, 20, 30, 40, 50 million per incident. It's not coming from the waste fund. It's coming from what's called the judgment fund in the government. There's this giant fund which is used to pay for lawsuits that the government loses. So it's not coming out of the waste fund. It's coming out of our budget.
Oh, well.
Yeah, this is nuts. This is crazy.
Let's go to Michael.
So just a couple of notes. I was a bit surprised to see you say that we have to go from AC to DC back to AC to transmit some distance on electrical power when Tesla Nikola prevailed over Edison because AC was better than DC. So I see DC in there and I'm wondering, okay, what's happened in the intervening 150 years?
There's a great book, a great book that's got Tesla, who, by the way, was certifiably insane, and Edison and Westinghouse. It's a fantastic book. I can send you the title.
Well, I was introduced to Tesla back in 1974, so I've been a fan for a long time. So I understand a lot of his work. So, and moving on, just a quick note: if we're talking about evacuation plans, if you go to YouTube and type in ABC7 live coverage of the Palisades fires, you'll see how these evacuation plans work out, because it's really unbelievable that I've watched. I lived on Hollywood Boulevard for a while out there, and boy, these people are sitting in cars with fires coming down, leaving cars, bulldozers are going through, knocking cars out of the way. It's just unbelievable if you don't have a good evacuation plan. But maybe we don't need these. I'm sorry, go ahead.
The former CEO of Southern California Edison, Harold Ray, lives in that area, and I was in contact with him this morning. And his house is not being burned up, but He says they're looking out the window.
Hmm.
He
Yeah,
lives in
it's really
Pasadena.
bad.
Yeah.
Yeah, unbelievable. Oh, yeah, it's really expanding. Um, uh, I saw a thing on, I think it was YouTube. I was hoping that I could find a link for you today. They're talking about, first of all, I read that we in the US achieved sustainable fusion reaction of several milliseconds not too long ago. Within 6 months, I read that. Then I read that the Chinese had achieved a 17-minute sustainable fusion reaction. Okay, I think they're getting ahead of us. Then just the other day, and I don't have the link, I'm watching something on YouTube where they're saying we are going to be building an operating commercial fusion plant within 3 years, and we're involved with MIT on this. Are you familiar with this at all? Because it's a game changer.
As a matter of fact, very familiar. I helped design the magnets for the fusion, the company that's out at Hanscom. Well, not at Hanscom. It's at where's the Surnavs at?
Devons.
Devon's, yeah.
Yeah.
So I was, but till I left MIT, I like to say I escaped, but I was involved with the high temperature magnets that are going to be useful. But 3 seconds versus 20 seconds, the step to continuous power. Remember the old saying that somebody said that sooner or later nuclear power would generate electricity too cheap to meter?
Yep.
Probably half of you guys have done research at a university, and then you realize that at universities, prostitution is still legal
Hey, watch it.
from the standpoint of getting research money and things like that. So
Yeah.
when somebody walks into your office and says, oh, by the way, 10 years from now, we're going to have an operating fusion reactor. You know the old saying, you can't bullshit a bullshitter?
That puts it in perspective. Okay. Let's
That I
go on to Marv.
understand that.
Thanks, Michael. Let's go on to Marv.
Who?
You're still
Muted, Marv.
muted, Marv.
Sorry. All right.
Yeah.
This is fascinating for a lot of reasons, but I'd say that most of this conversation is what I would call supply side as opposed to demand side. So
Yeah.
we have a very moving target
Yeah.
on the demand side. Just to give you some numbers, and obviously I have a tendency to bring things back to AI, but in this case, totally appropriately. Couple of points. Last week, Microsoft announced they're going to spend $80 billion on data centers this year.
Yep. Yeah.
Most of that in the United States.
Yep.
The estimate, I believe, from the EPRI was that in 2023, data centers use 3% of the total energy in the United States. The estimate that they put out is around 12% by 2030.
Yeah, I hear 7% actually, but who's arguing?
Well, and I've seen numbers as high as 20. And if you go back a couple of years, they wouldn't have projected as high as we're projecting now. So the acceleration, thanks to NVIDIA and other things, is dramatic. And I'm not even talking about the conversion to electric cars or heat pumps, I'm talking about just that data center need. To give another perspective, we've been doing that for a while. Netflix in the evening, especially during a live broadcast, accounts for 80% of the internet traffic, 40%, sorry, of the internet traffic in the United States. Some have estimated it's lower than that. But a minute of download time costs about 0.003 kilowatts.
Yeah, that's what I was
hours.
remembering. Yeah.
But a single query on GPT is costing about twice that, and that query is happening, in fractions of a second. So and the acceleration of building of these centers, which is why TMI was brought back onto the table, is greater than I think people have estimated. But and one of the other interesting things is most of the companies causing this have internal stated policies with the SEC about being carbon neutral by 2030. And so they have this push and pull. You're either no longer competitive or you're violating your fundamental policies that you've stated to your stockholders. And even if they're trying to do both, where does the energy come from is really my question. Is it possible for those two things to meet? And 2030 is not a magic day. It's just one everybody's agreed on. The acceleration is expected to dramatically continue. NVIDIA announced this week a desktop, basically standalone data center. They're going to be extremely power hungry. They're only going to cost 3,000. They expect to sell millions of them. So you're going to have another non-data center, massive sink of energy. These things probably going to be water cooled. It's a little unclear. But for $3,000. So the demand for energy is going to, under almost any scenario, dramatically increase. At the same time, we have an aging infrastructure. How do we deal with that?
Yeah, I mean, you making my point. I mean, it's it's actually worse than what you're saying. And that is, where do you think the critical communications from the Defense Department go? They go through these data centers. And what's happening is, if you, our good friend Elon Musk came up with these low orbit satellites to basically make the communications independent of the internet. And so the Defense Department is having to face the possibility that they need to establish their own non-interruptible communication center, and that's going to be space-based. So you got a data center, if it goes down and your communications are going from NORAD to wherever, you're screwed. And so there's a whole national security issue that's going on here that is, that people don't even hear about. But if you think about it, that can be pretty tough. And to think we're not going to have a blackout on one of these things, well, that's possible.
Yeah, we have multiple single points of failure.
Multiple single points of failure. I'd like to hear, who's the ISO person?
What's your question?
One of the participants is an ISO person.
Yeah, that's me. I'm Roy Harvey.
Yeah. Have I been lying through my teeth?
No. Quite accurate. I will say that the ISO does have a backup data center in Connecticut that backs up the main data center control room in Holyoke, Mass.
Yeah, we used to be able to visit Northfield Mountain, but we can't anymore.
I was just there this past summer.
But you're an employee.
To the top and well, you can't go inside underground. Yeah. It's true, but you can go see the pond up top on top of the hill.
What people don't know, the ISO, this ISO New England Center is in Northfield, Massachusetts, and there's a pumped storage facility, Northfield Mountain. If you can ever wrangle a tour of that, boy, that's fascinating.
I'd like to add another point to this, and that is
let me move the conversation forward. We have two more hands.
Can I just quickly add something to it?
Yeah.
The data centers are going through a massive transition and the economics are changing dramatically. The data centers that basically currently exist are shared sites for some processing, but basically storage. And economically, they're a challenge because they're run by companies who lease out. And so therefore they're like landlords, and they can only lease out what they have, and they're not going to invest beyond what they can for leasing. Microsoft and everybody else are moving to a single vendor data center that they own, which means there'll be no cap on how much they're going to try to use to be a step ahead of Musk or anybody else. So the data center, so what I've been reading is the data centers, because of the shift from the landowner, from the landlord-based system to a residential system, basically, of the companies utilizing it, owning it, and expanding it as they want. And obviously, they're going to buy as many, NVIDIA 200s and 300s as they can. We're talking millions and millions of them. I believe that spike in terms of data use of energy demands is going to be higher than anticipated because of that one thing, the economics of not having to rent from somebody who has limited resource. You have unlimited resource. And I'm just curious how much thought is being given on, the supply side to the fact that they cannot even project the need 5 years from now.
Let me ask you guys a question. Where do you think we get the stuff to build these things from?
Digging and destroying the environment.
Two places, China or Taiwan.
Mm-hmm.
All right.
Yeah.
Thumb through that and think about that for a little while.
Yeah, I mean, TSMC produces 92% of all the AI chips in the world.
Taiwan.
Taiwan, TSMC.
Yeah. If you
Yeah.
go on the web and ask what's happening in a little island called Guam.
Yeah. So I'm now curious how, from a systemic point of view, call it governmental or international, they are planning for that reality. Obviously, turning on a retired nuclear energy facility is almost an effect as opposed to a cause. And I'm just wondering how they're planning for the changes in cause.
That's a big question.
Yeah, let's move on. Let's go to Eddie. Go ahead.
Yeah, I just have one comment. I actually worked for EMC for a number of years and did an enormous survey of power consumed and the power reliability to data centers. In fact, there's a complete worldwide survey that I managed to do using EMC machines. But one of the things that comes to mind with nuclear is that they have a service period, which means that when they're down, they're going to have to draw power from somewhere else, because normally these data centers are located at the junction of two grid systems. But if they're planning to use one grid system and then basically have a backup from domestic supplies, what's going to happen there?
Yeah, what happens usually is the grid operators know the schedules for the nuclear plants. You're right; they have to refuel, and they're going to what are called 24-month fuel cycles. So they only have to shut down for about a month or so every 24 months. But you're right; if it's a 1,300 or 1,400 megawatt electric plant, then they have to plan for that. But that's actually one of the advantages of nuclear, in that the fuel supply is stable enough, the schedule is known. So it's not like a coal plant or something like that, which could go out, it's not as predictable from the standpoint of operational flexibility as a nuclear plant. But you're absolutely right. If you go out to Palo Verde sometime, out in just outside of Phoenix, they have 3 nuclear plants on the same site, and they coordinate with the grid operator which one is being refueled and which one is not. You're absolutely absolutely right.
But that puts an enormous stress on the rest of the grid,
Unless you plan.
which has to,
unless you plan. Yeah.
Pete.
Yeah, Ron, you did not mention the renewable portfolio standard as a driver of this variability.
I didn't want to have to wear a Kevlar vest.
Had we the chance to do it again, we should include the storage in any offering from any of these variable sources.
Yeah. The thing is, the system is so distorted by the regulatory environment and the social environment that's having a big force factor on the regulatory and the environment, such that we've been forced to do certain things by this portfolio business.
Yeah.
You know, we're a society, we can decide what we want to do. And so that's what we're deciding, you know, that's what we're deciding. But
my
the
point was
idea-
that we should include storage in renewable
Yeah.
offer.
And I'm guessing that if the system were allowed to operate a little bit more, and I hate to be called a pro-market something or other, fascist bigot, whatever, but if the system would have been allowed to operate more freely, I think the storage issue would be much more easily, would have been addressed. If you look at one of the new SMRs, and it's the one, by the way, that's being funded by Microsoft. And it's, believe it or not, it's being built in bloody Wyoming. Man, they haven't seen a nuclear plant in Wyoming ever. But they're going to build a small modular reactor, and guess what? It's going to have a molten salt storage facility for heat to be used to generate power, just exactly like you're saying. And that's a great idea.
Yeah.
That is a great idea.
Yeah.
But
You're
they got to
gonna
build a
have to-
small, they got to be able to pay for the darn plant to start with.
Yeah. We have Michael's hand up, and Michael, you have the last question today. Go ahead.
Well, it's my job as an independent inventor, somehow that found his way into such a group as this, to occasionally be provocative. So I would say that I think this whole conversation might be moot within 5 years, because I believe that if you put $1 billion on the table for someone to walk into the room with a machine that produces more power than it consumes from magnetics or heat, you're going to have a line of inventors. And some of them are going to have a machine that works. And I think one of my friends, if he hasn't been murdered yet, has such a machine. So I do think that 0 point energy is not all that far away. And if we can achieve that, we're going to have a very different world. And I think the thing that will be required is to remove control from the hands of those people who do have it now into the hands of people who really want a better world and free energy. And so don't be surprised if within 5 years you see something like that. And I will try to track down Troy and see if I can drag him in front of this group.
That'd
That'd be great.
That's by the way called the free market. And the last person that was able to do what you're suggesting, they crucified him 2,000 years ago.
Yeah, that's true. But there's been a number since then too, but not as impressive and long remembered as him.
All right. I think this is a good place to bring our conversation to a close. Ron, I want to thank you for joining us, for the perspective on the grid, for the commentary on the issue of managing waste, and especially for the whole question of how we're going to put together a successful and safe recommissioning of decommissioned nuclear plants, if we can do it. Thank you very much, Ron. Take care.
You're welcome.
Thank you. All right. See you in 2 weeks. We're going to have a talk on tissue engineering by a guy named Peter Searson, who was a number of years ago was a postdoc of mine at MIT. So it's going to be very good. He's at Johns Hopkins today.
By the way, the nuclear engineering department, I think, has invited the new incoming Secretary of Energy to give a talk at MIT.
When is
I don't know when it'll happen. But that's something to keep
makes
an eye on.
sense. That makes sense. That'd be a good thing to do.
Yeah.
All right, folks. Take care. See you in 2 weeks. Bye-bye. Cheers.